Hi, I am Neil and I welcome you to NCS Forum. Today we'll take on quantum computing and the advancements, and we'll try and understand how quantum computers and the process of quantum computing works. So let's deep dive into this magical world. Ever since mankind has come into being from Homo sapiens neanderthalis to Homo sapiens sapiens, we have always been at war with each other to capture or get a gain of the resources that is available to entire mankind. We do not know how to share, and we are scared that if we share, then the other will get a substantial advantage over us. Be it the Battle of Plassey, the Panipat War, be it for land and fame, fortune, glory, starting from Napoleon Bonaparte to World War I to Adolf Hitler, World War II, where mechanization played a key role in providing a superiority or a competitive advantage over the other. Now we have entered what is called the digital era, the era of computers, supercomputers, and quantum computers. With quantum computers, we are probably sitting at the edge of a new world and probably have already started a war, World War 3.1, as I say it, for gaining supremacy over the quantum computing world. If one gains an edge over this quantum computing world, in this magical world of quantum computation, then they gain supremacy, quantum supremacy, over the others. Be it in the form of enhanced security protocols, which only a quantum computer can either help develop or help break. Mathematician Hannah Fry has this to say. Let's see what she says about this war that has started now.
But there is a dark side, because they will come with the ability to decrypt all internet communication. Experts say there is now a quantum arms race. I'm Professor Hannah Fry, mathematician and writer. I want to know where quantum technology will take us, and with international security under threat, who will come out on top?
Just look at the numbers that is stacking up in terms of investments done by countries in the field of quantum computation. This is how the numbers stack up.
China are betting big. They've invested over $15 billion, more than 3 times any other country. They have dozens of new research institutes committed to quantum and hold more than half of all patents in quantum technology. As you can imagine, it's been an expensive endeavor. Do you have any idea how much IBM will have spent on this quantum program?
We haven't broken out, but I think it's fair to say it's like obviously many billions of dollars of investment. Today, in our world of technology, if you're not investing at that scale, it's very hard to be a global leader. Well, I think we acknowledge the fact that in this technology, in quantum, right? But we're seeing it happen, by the way, in other areas like semiconductors and so on. There is not only a big economic dimension, but there's a big national security implication as well. Quantum falls squarely within the category of like sensitive technologies from that perspective.
Quantum scientist Olivia Lanes is showing me IBM's newest experimental machine.
So how does quantum computing process work? The theory is complex and mind-boggling.
What it comes down to is that nature is quantum mechanical. When you get down to molecular and atomic interactions, nature does not obey classical physics. It's just a very crude approximation. And if we really want to understand how nature evolves in time, we have to have a system that obeys quantum physics.
Please subscribe, like, and share this video among your friends and family. And don't forget to press the bell icon so that you stay notified for all my upcoming videos. Thank you.
Computers are made up of transistors. Transistors work on the principle of 0 and 1. So it's a intermingling permutation combination of zeros and ones, and these are called bits or binary digits. Now, quantum computers work on not only 0 and 1, but everything that can simultaneously coexist between a 0 and a 1. Sounds very complicated, right? Yeah, it is. Let me try and simplify this explanation. So we have a coin. The coin has a head and a tail, right? Now when we flip the coin, just visualize that when the coin is in the midair and rotating on its axis, what is it that you see? Do you see only a head or only a tail? Or actually do you see both at the same time? This is the principle of juxtaposition, and this is what quantum computers use for it to work. So the zeros and ones exist separately as well as simultaneously and concurrently. Now, another weird thing about this is the zeros and ones exist in an atom. So transistors or any matter is made up of molecules which are made up of atoms. Protons, neutrons and electrons. So it is the electrons that store the energy, right? So the zeros and ones and everything in between a 0 and 1 is stored in that electron or in that atom. Let's put it that way, simplistically. Now, we know of an atom. Let's say we are looking at, let's say my jacket, right? So this is made of a molecule and it is made up of atoms. So I am wearing this jacket in this moment in time in Earth, in Delhi, India, Earth. There are multiple parallel Earths existing simultaneously, and this is a key postulate or theory in quantum physics, that you have multiple universes, multiple Earths, multiple NCs existing in the same point in time simultaneously and concurrently. And quantum theory also states that through a theory called quantum entanglement, my atom from Earth A can communicate or can be linked to atom B of NC in Earth B, which can be linked to Earth C, and so on and so forth. Which means theoretically that you can have infinite number of atoms intermingled with each other, vibrating at the same coherent frequency that allows for data to be stored and transferred at the speed of light between each atom of every single NCs in the multiverse universe. Dr. Michio Kaku has explained this process. It works on a theory called Schrodinger's cat. Let's hear him out. Let's see what he has to say. And I will after that post another video that again explains the same thing in a different manner. Both are simplistic, and just whatever I've said right now is exemplified in a much better way in those two videos.
At the fundamental level, quantum mechanics can be reduced down to a cat, Schrodinger's cat. Let's take a box. In the box, you put a cat. And the question is the cat dead or alive? Well, until you open the box, you don't know. It is alive and dead simultaneously. It's in a superposition of two states. In other words, the universe has split in half. In one half, the cat is alive. In the other universe, the cat is dead. That's the basis of the quantum theory, that until you make a measurement, the cat can exist in both states simultaneously. In fact, in any number of states simultaneously. The cat could be dead, alive, playing, jumping, sideways, sick, any number of states. Now, why am I mentioning this? Because this summarizes the power of quantum computers. Quantum computers compute on parallel universes. That's why they are so powerful. When we talk about digital computers, we can measure their power in terms of bits. For example, spin up, spin down, zeros and one, would constitute 1 bit. For a large digital computer, we're now talking about billions of bits that are modeled by transistors. Except now quantum computers talk not just about spin up or spin down, but everything in between. That's called a qubit. 1 qubit represents all the possibilities of an object spinning between up and down. Thousands of qubits can now be modeled with the latest generation of quantum computers.
Imagine that parallel universes do exist. So you have two universes that are exactly identical in every aspect, from the vast horizon to the tiniest atomic detail, but with only one difference. And that difference lies in the value of a tiny element called qubit. A qubit is somewhat like a transistor in a classical computer. It has two distinct physical states, which we label as 0 and 1. In a regular computer, these states are mutually exclusive. That means the device can either be one or the other, and never anything else. But in a quantum computer, this device can be in a strange situation where these two parallel universes have a nexus point. As you increase the number of these devices, every added qubit doubles the number of accessible parallel universes. So when you have a chip like this with about 500 of these bits, you have something like 2 to the 500th power of these parallel universes existing within that chip. We can think of it as the shadows of these parallel worlds overlapping with ours. If we're smart enough, we can dive into them and bring them back to our world to make an effect. Quantum algorithms take advantage of the entanglement and parallelism of qubits. This gives them a considerable edge over traditional algorithms for specific problem domains. They also get information from qubits at the end of a calculation. But this presents a unique challenge. When you measure qubits, they collapse into a single state, which eliminates their superposition and entanglement. So quantum algorithms use advanced techniques to draw meaningful results from measurements before this collapse happens, which would then maximize the benefits of computation.
So that brings us to the end of the second chapter of quantum physics, quantum computing, quantum computers, which explains how the entire quantum computing process works through quantum physics, qubits, juxtaposition, and quantum entanglement. A fun thought just came to me while I was reviewing the other videos and understanding what quantum physics is trying to say about quantum computing is that can one use quantum physics to decode a dream? If it were to be done, then it would go something like this probably. Let's say Mr. NC in planet Earth here, A, and Mr. NC in planet Earth number 3 of the multiverse, assuming that time is a constant, are both sleeping at the same time right now, midnight. And what happens is, because the atoms of Mr. NC3 is entangled now with the atoms of Mr. NC1, which is me, and both the atoms are in coherence stage, which allows for a stable entanglement to happen, then probably through juxtaposition, the experience of Mr. NC3 moves somehow to Mr. NC1 and vice versa. And therefore, Mr. NC1 starts visualizing all the experiences that Mr. NC has gone through the day or week or whatever. And similarly, Mr. NC3 goes through the experiences of Mr. NC1, thus resulting in a dream. Anyways, end of fun fact. Thank you for watching this video and supporting me and motivating me to continue to make videos like this. I hope you guys have a great day, great week, great weekend, a great Christmas. Take care, stay blessed, and stay tuned for the third chapter of quantum computing and quantum physics. Bye.